In this video, I will explain how symbology is defined for different types of drainage and utility nodes. Here on the left, we'll look at the properties for a node. And in the properties, we're going to be defining three different types of symbologies. We'll have a point feature symbology, connection region feature symbology, and a solid feature symbology. Let's start with the point feature symbology. Here in the point feature symbology, we're going to be defining a plan and profile element template. The plan element template is going to control how the element looks in plan view. So if I take a look at the element template for this head wall, I have a plan cell that's being pointed to. Then the profile element template is simply going to control what level, color, line style, and weight the element gets drawn in profile. Next, I'll talk about the connection region symbology. That's actually going to live under the linear symbologies. Let's take a look at the connection region for an inlet. So if I take a look at that element template that we're pointing to there, we're just controlling the level, color, line style, weight, and the class of that element. So what I mean by connection region, if I select one of these conduits and I go to move one of the pipe ends around, you'll see an orange cross at the end of my cursor where I'm allowed to connect the end of that conduit to a node. And that will be there on either side. And these are connection regions. So we have a connection point here in the middle. We also have a region here around the inside ring. I'm going to turn off my construction class and you'll see that ring disappears. So that's what we're controlling with that symbology, is what that connection region element looks like and what level it's going to be on. The third type of symbology is going to be the solid feature symbology, and that's how we're going to get what we see in our 3D model. So this is going to be slightly different for different types of nodes. I'm going to start with a head wall. So when we look at the symbology for a head wall, we have just the bottom template that's going to be defined for this. And that's because we don't have a varying height. So the size of the cell is going to stay the same. As we change the invert or ground elevation, the whole cell is going to move as a unit. So for instance, if I go and select this flared in section and then change the invert elevation, you'll see the whole cell move up as one entire unit. Whereas if I do the same thing with this inlet, you're going to see some extrusion happening between the top and the bottom part of this cell. So now looking at an inlet symbology, see how we have a top and a bottom element template. And if I take a look at these element templates, those are pointing to top and bottom 3D cells. So I have a top cell here, and then a bottom cell here. And the reason why we have the two cells is because things like an inlet or a manhole are going to vary in height, and we'll have an extrusion that happens between the top cell and the bottom cell. See something similar happen with this utility pole. So I'll change the invert elevation here to 10. And you can see between the top part of the cell and the bottom part of the cell, I have this section that extrudes between so that we can reach a new invert elevation. So when we're creating the features for a node, we're going to have three different types of symbologies that we'll be creating: the point, the solid, and the connection region. And then when we think about element templates, for any node that extrudes, we're going to have a plan, profile, top, and bottom. And then for any that does not, like a cross section or a head wall, we're just going to have a plan, a profile, and a 3D.